analysis. Here are the notes for chapter 1, lesson 3. So we're going to talk about defining domain and range and identifying domain and range, and then looking at our different functions or relations and making sure we understand and can read domain and range of these functions and relations. So just a quick reminder, the domain is the x values that are being used, the range is the y values that are being used. So if you have something like a continuous function, like we have below, there we go. We have a continuous function like we have right here. This is a continuous function because see, from its start point from the left to its end point to the right, we don't have any gaps, right? So it's not just a bunch of points, it's actually a continuous, infinite bunch of points from here to here. And so domain is always kind of the easier one to tell what it is because we naturally as English speakers and readers, we read left to right. And so because we read left to right, it's kind of easy to see left from right. Oh, this is where we start and this is where we end. So this is my first x value and I cover all the x values from here to here where we end. So domain is usually an easier one to read and figure out. So on this one, again, right here, we've got -3 as the lowest x value we use. We keep going and going and going. We're covering all these x values, and the highest x value we use and where we stop is 1. Okay, so I think I already wrote it out. Yep, I did. So right here, we write out, and you'll just do it again just so you can see this. So -3 is my lowest x value, then less than, okay, because lowest to highest, so it's always smallest to largest. So that means you always use less thans. X in the middle, I call it the less than sandwich, right? And then let's get a less than or equal to in there. And the reason we have a difference between those is because here we have an open circle. So -3 isn't one of the values that x can be. Okay, but everything above -3, anything above -3 up to and including 1 is an x value it can be. And so again, including 1 because that's on a closed dot, right? As you can see there. Okay. So now what I'm going to do is I'm just going to insert that into here. Okay, there we go. And that's your domain. Let's put it right there. That's your domain. Okay. Now your range is a little bit harder to read sometimes because as English speakers, we're reading left to right. Domain is lowest to highest for y values. So it goes down to up. So your endpoints may not necessarily hold the lowest and highest y values. So you kind of have to be a little bit more careful with range. The endpoints don't necessarily indicate what the lowest and highest y values being used are. In our case, in this particular case, they do, which is nice, right? The lowest y value we ever use is a -4. Notice we hit it twice, right? And the highest y value we ever use is a 0. Okay. So we are counting this as just using it as the open circle for the 0, just so you know, because that's what we've got right here. Okay. I did color code this, by the way, for you, just so when you're reading it on your own, you, as you're reading, identify that burnt orange with the domain and this like kind of teal with the range. Okay. So now let's type out the range for this. Oops, I don't want one of those. I want one of these. There we go. So I'll start over, right? So -4 was the lowest y value that I used. And then I believe we were equal to -4 because we had the dot. So we're going to need a less than or equal to. Then y in the middle, because now we're talking about the range. And then the highest y value that we're using is this less than to 0. Okay, and so I'll insert this guy now. And there it is. Oops, I have to grab it a certain way. Oops. There we go. And there's your range. Okay, so that's where we're getting our domain and range. Okay. Notice I used inequalities to describe my domain and range between inequalities. So my variable was between two less than signs. You could also use interval notation, which you may have learned in geometry. You may not have. Interval notation used to be in Algebra 1, and then they moved it. So it might be me that's in charge of interval notation for you for the first time. But interval notation is like a between inequality without the less than signs and without the variable. It's an open circle would be an open parenthesis, and that's next to your lowest number, comma, and then your closed bracket would be like a closed dot next to your tallest number, largest number. It's the easy way to go. I actually really enjoy interval notation. I find it to be really simple because you don't have to worry about less thans in your variable. It's like writing a point, except if you have a closed dot at the end, it's the hard bracket, right? So you kind of think of it that way. All right, so that's the first one. Oh, here's Ray. Okay, so now we're looking at another betweenie, right? So here, open circles, open circles. Okay, so let's read left to right first. So -3 all the way to +3. So that's the x values that I'm using. So -3 is less than x, which is less than 3. Now let's do down to up. So see, the lowest down we go is -2 all the way up to 4. And see, and that's an open circle on each of those. So that's -2 is less than y is less than 4. So you can see we've got those written out here. And I know I had them written out above too, but I just wanted to show you how I'm going through where I'm getting these values from. Okay. So here there are no closed brackets anywhere because we had no closed dots, right? So in interval notation, it looks like points, but it's describing the domain and the range as two separate things. Okay. So it's describing those. So you kind of have to know that you're talking about domain or range for those. Okay. So sometimes, and in this case, in both of these cases, we see it. Sometimes as we're talking about our domains and our ranges, the answer is all real numbers. That's because in this case, any x value is going to get used because when a computer model like this goes off the page, doesn't have arrows at the end, we assume it continues, right? So this is continuing in both directions for the x's. It's coming from negative infinity and it's heading to positive infinity. And so because it's doing that, we call this domain all real numbers. However, it's not that case for the range. The range has a definite stopping point. These y values are never going to get lower than -5. They go infinitely up from -5, but they're never going to be lower than -5. So we call this y is greater than or equal to -5. Okay. And again, this was down to up. So think of it that way, right? As lowest down, we go up to infinity. Let's say you have a highest and you're heading down to infinity. That would be y is less than or equal to 2. And the reason I say that is because if 2 is the highest, we're never going any higher than 2. All the y values have to be smaller than 2. So that's how I know which direction I'm going as far as less than or greater than. And notice again, I have a domain of all real numbers. So all the x values are what my domain is in this case. We call that all real numbers or this fancy dancy R right here. If you're writing all real numbers in interval notation, you actually put an open parenthesis, negative infinity to positive infinity, and then open parenthesis again, because infinity is not a closed concept. It's open to the fact that there is no smallest and is no largest. If you're talking about interval notation with a single inequality like this, whichever end is the infinity, that has an infinity and an open bracket on it. Open parenthesis on it. So in the case of y is greater than or equal to -5, -5 is the lowest number. So that goes to the left and has that bracket because we can be equal to -5. while the infinity goes on the right because it's the positive infinity, it's the highest. So think of when you're thinking of interval notation as far as these go, you can actually think of infinity as numbers. It's your highest number or it's your lowest number. Like here, y has to be less than or equal to 2. Well, negative infinity is your lowest number there. Okay. Whenever you're writing interval notation, you're always between two things. Okay. You're always between two things. And one of the things you can be between is your infinity. So that's how those particular things work. Okay. And again, you have these notes so you can look back as you're doing your domains and ranges for your homework. There's another good one. Have a definite start point at -30 right here. And so going from there, again, if it's kind of heading off the page and doesn't have an arrow at the end, it is assumed to be going on to infinity. So this is going on to infinity in both directions, both increasing in x value and increasing in y value. Okay. So your domain is x is greater than or equal to -3 because that's your lowest x value, left to right. Your range is, of course, starting at 0 and going up from there. So your range is y has to be greater than or equal to 0. That's not too bad. Down here, this guy's the tricky guy, right? Because you've got this function, it is, I promise, going in either direction. Okay. But there's one value that clearly there's an asymptote there. And that value is an x value of 2. Neither side of this function can be equal to 2. So your entire range here is, sorry, your entire domain here is that x cannot be equal to 2, but it's everything else. So you can just state that as your entire domain. Now, also notice that as we're approaching a y value of 0, we continue to not touch or cross it. We don't end up going along that line either. And so that means your range has, and they're showing it in the picture, and this is actually kind of cool the way they're showing it in the picture. It has like this open hole in your range. It has like this open hole in your domain that is just not going to get touched or crossed, right? And so those open holes, that's how, if I have a situation like that, I state my domain and range as you're never going to be an x value of 2. You're never going to be a y value of 0. And so that is my whole domain and range. If that's the case for interval, you talk about it in both directions, right? It's negative infinity up to 2, but it doesn't include 2. And that's what the little u guy means. This guy is a union. We're connecting these two things. And 2 is also that to positive infinity, or in the case of the range, it's 0. So it's just saying you can't be that. Okay. You can use this, or you really can. So rather than worrying about all this union symbol, you really can just do x is not equal to 2, y is not equal to 0. Okay. And that is, in this case, the much easier way to write about this. Okay. So here's just some reminders of what goes together. Closed dots go with inequalities that have equals at the bottoms, and the closed brackets. So notice those are all like extra filling in, extra piece at the bottom of your less than or equal to, or your greater than or equal to, right? The extra piece at the bottom. Hard bracket, so there's the extra piece kind of in, right? Whereas this is more open. So the open circle has no equal to underneath its inequality signs and softer open parentheses. And so that's why I try to like say closed versus open to kind of get your mind thinking about looking for those pieces right there. Okay. This is all infinity stuff, right? So if your arrow is going on in both directions, it's all real numbers. So it's that fancy looking R, and it's negative infinity to positive infinity, covering all of your numbers. And of course, we have to do some examples, right? So, first of all, is this a function or a relation? So let me see if I can freehand this guy. Okay, is this a function or is this relation a function or not a function? I'm going to circle function. I should have changed the color, but I will. If f of x equals -3, what are the values it could be? Oh, let's look. Okay. And f of x equals -3, so that's the output. What are the x values? Okay, so the output is -3. Well, let's look. 1, 2, 3. Aha. There is one input that gives me an output of -3, and that would be an x value of 0. So what are the values that x could be? 0. Oh, I need to input typewriter. There we go. 0. There we go. Okay. What is the domain of this relation in inequality form? Got it. Okay, so I'm going to need math type down here. In inequality form. Oh, I don't need math type. I can use typewriter because I'm going to write out, typewriter please, all real numbers. Interval notation, I'm going to need my math type. So let me get down here for my math type. So interval notation, I'm going to need either parentheses or brackets. Let's think about it. Oh, well, if it's all real numbers, then it's -infinity to positive infinity, right? So parentheses, and let's get my infinities here. Did I miss them? That's not infinity, though. It's close. It's not quite. I guess that's the best I can do. Yeah, I guess so. You guys aren't seeing an infinity that I'm not seeing, right? Okay. Well then. Oh, maybe in here. Wait, what are you? Any infinities? These are all matrices, so I doubt it. Yeah. Nope, no infinities there. Darn. Yeah, I guess that's the best I can do. Yep. Okay, well, let's use this guy. Negative infinity, weird looking infinity, to positive infinity. There you go. Okay, let's insert. Yeah. Weird. It's just like kind of chopping off the end. I don't like that. All right. What's the range? Well, the range has a definite bottom. So let's just kind of look. So this is the lowest that we go, right? Lowest to highest. So this is 1, 2, 3, 4, -4. So y equals -4 is the lowest that we go. So in inequality form, that would be that y is greater than or equal to -4. Okay. Next, let's see, interval notation. Okay, so we have to be greater than or equal to -4. So that means -4 is my lowest number. Oops. Just inserted that guy a second time. I don't want him. I want a new one. And that would be -4 up to, oh, wait, I need the hard bracket because -4 is included. Oh, wait a minute. How do I get the hard bracket then? Is that not an option on my keyboard? Yeah, it is. There we go. Up to, I need that funky infinity again. It doesn't really have an end. And, what are we doing? There we go. Okay, insert. Half the battle is just figuring out this math type. It's in here. It's not in my laptop. It's on the internet instead. And there we go. All right. That's what we're looking at. Let's look at another one. Answer the following questions based on the graph below. Cool. Is this relation a function or not a function? Well, no x values repeated, so still a function. Let me be smart about how I do it this time and do a different line color. What color line do we want? Red. No, I'm a blue person. Blue fan. Okay. Well, that's not the blue I would have chosen, but that's all right. Works. Okay. If f of x equals 2, that means the output is 2. So my y value is 2. What are the inputs? Got it. So a y value of 2. Oh, look at this. Right here. Right here. And right here, so this one we're going to do a little bit of a guessing game, right? Because it's not on an exact point. But that y value of 2, this line right here, excuse my messy freehand, is all y equals 2, right? So because that's all y equals 2, anywhere, any x value that is on this line, is touching this line with this function, is going to have an output of 2. All right, so let's put those on there. Actually don't need that. I can just type right. So let's see, we've got 2. So an x value of -2 and an x value of 0 and an x value of, let's see, 1, 2, 3, 4, 5. So let's say halfway between 5 and 6, let's say 5.5, just to keep it kind of easy for notes right here. There you go. Okay, what is the domain? What is the domain? Let's look left to right. So let's see. The furthest left we go is 1 to -3. And the furthest right we go, 1, 2, 3, 4, 5, 6. So -3 to +6. And it looks like we include both. I'll scooch myself back up here. And we'll go -3 is less than or equal to x, which is less than or equal to +6. All righty. Next, we'll do interval notation. So that would be brackets, right? Hard brackets that's including -3 to +6. So we'll do, oops, I did it again. Ooh, very Brittany of me to say that. Okay, edit. There it is. All right, we're including, so -3, 6, and we will end that guy. And insert. There we are. It's just, yeah, but then it's still there. I don't want to check mark. Okay. What is the range? Okay, down to up. So notice the end points here aren't my range, right? There is lower. So this is the lowest that we go. And so let's count down. That would be 1, 2, 3, 4, 5, -5, all the way up to, it does include one of the endpoints, 1, 2, 3, 4. So -5 to +4. So let's edit that. -5 is their dots, so we're including. So less than or equal to y, which is less than or equal to +4. That's my range. And then, okay, so next, I think if I type inside that one, it would mess up what I already had. So let's do it again. Now, we'll start with -5. Let me just get on the other side of it. We need a bracket, and then we need a parenthesis, and then we're going up to 4, and we're including 4. Okay. So you guys can kind of see where I'm getting all these from, like how I'm figuring these things out. I think you'll be all right. We'll just do a couple of these guys where there's domain restriction pieces, right? So there's a domain restriction on this function. And the reason I know that is because there's a variable in a denominator. All you have to do to figure out what that domain restriction is take the denominator and set it equal to 0. Okay. So if you take 2x minus 10 and set it equal to 0, all of a sudden you have an equation to solve. You add 10 to both sides, so you get 2x equals 10, and then you divide both sides by 2, and you get x equals 5. Now, what you're saying here by having done that is you're saying that x can actually not be equal to 5. So we're saying x is not equal to 5. That's the domain restriction. X cannot be equal to 5. Okay. And why is this a domain restriction? Because a denominator of a function can't be equal to 0. All right. Now, when you're looking at something like this and it asks you what's the domain and range of this guy, just plug it into your graphing calculator, look at it. You're going to know what your endpoints are. It's a square root, right? So it's going to continue on in infinity. It's a positive square root. So it's going to continue on to infinity in both directions. I don't have a graphing calculator on me right this moment, but plug that guy in. I know. I never thought I'd say that. Oh, wait, hold on. Who's this guy? Let's see if I can plug him in. Square root of 6 minus 2x. Of course, I can't see the square root right now because I've got this crazy thing. There it is. Square root. Oops. There we go. Of 6 minus 2x. Okay, there it is. Oh, the minus screwed me up. It's going the other direction than I thought. Okay. Cool. So here you go. So this is, think about it this way. This is the highest point is 3, 0. So the y is increasing into infinity. So your range is going to be y is greater than 0. And the x is, of course, decreasing into infinity. So it's going to be x is less than or equal to 3. So let's get that up there. I'll do them both. X is less than or equal to 3. And y, oops, oh, I can. That's awesome. Y is greater than or equal to 0 because the y is increasing. And if you want that as interval form, that would be negative, negative, weird at infinity. So weird. Where is the end of that? To 3. And this is not an end parenthesis. This is a bracket at the end because we can be equal to 3. And then we've got the lowest value. So this is going to be a bracket on this end is 0 to infinity. So again, with the weirdness, the half infinity and then parenthesis because we parenthesis the end of that infinity. So insert it. There's your answer. There you go. Phew. Found a graphing calculator and I didn't have one right on my screen. They still haven't put my graphing calculator on my laptop. That's why. Okay. This function maps the domain given by the set. Oh, so this is not continuous. So this is not continuous because we're just using these domain values to plug in. So really what you're going to do is just plug in each of these x values into this and just get out the matching y value. So when I plug in negative 2 squared is 4. 4 plus 5 is 9. So that means 9 is a value in my range. So right off the bat, I can eliminate nothing. Okay, let's keep going. Negative 1 squared is 1. 1 plus 5 is 6. So 6 needs to be in my range. So look around. All right, I can eliminate choice. So many random things happen. Well, I can eliminate choice 1. I clicked this, didn't I? I can eliminate choice 1. Hey. Zoom in and let me write. There it is. Bye. I said 6. Yeah, so choice 2 is gone too. Kind of thought that was going to happen. I'm thinking it's choice 3, but let's get there. 0 squared is 0, and 0 plus 5 is still 5. So, yep, we still have choice 3 on the table, and we still have choice 4 on the table. Now let's try 1. 1 squared is 1. 1. There it is. So no negatives. Yep. So it's going to be choice 3. That was an excellent 3. There's an excellent circle around my 3 there, if I do say so myself. And there we have it. Alrighty, guys. So that should enable you to now do the homework. So I gave you pictures. Parts B and part C is the domain in both inequality and interval notation, and the range in inequality and interval notation. So that's why there's the and line. So the top line for B is the inequality, and the bottom line is the interval notation. And like I said, look back up at my interval notations. Those are actually easier than inequalities for a lot of people. And then notice these questions are just like the last 3 that I just did. So just do the same thing I did on that. Just real quick, because, notice I was sitting here like, oh, I don't have a graphing calculator. I guess I can't do that. And then I went over to here. So Desmos has a graphing calculator. www.desmos.com/calculator, right? So this is just a quick graphing calculator. You do have to type in your y and equals first, but then you can type in this part right here, which is what your homework looks like. See, your homework is here. Real quick, watch. I'll do it for you because I'm right here. What was it? Negative x minus x plus 3. There you go. Okay. Do that right now, right? Domain and range right now on that. On that question, since it's a short answer, you only have to tell me one way or the other. So when you get to pick yourself, you only have to pick writing your domain and range as interval notation or as inequality. You never have to write it all of the ways, other than the first couple on this homework, just to practice. So there you go. All right. Well, thus concludes our chapter 1, lesson 3 notes. So I shall be seeing you for chapter 1, lesson 4 tomorrow, or whenever it is that you're watching these videos. So yeah, have a wonderful day or night, and I shall be seeing you soon. Bye, guys.